Chapter 9 Exam Review. Number 21. So we're looking at a 30, 60, 90 triangle, right? We have the 30 and the 90, so we know that this remaining angle is 60 degrees. And we should know our triangles. They're on our review sheet on how to move around the 30, 60, 90. So from the hypotenuse here to the side opposite 30, you're dividing by 2. And so we get 11 square root of 3. And then when we move to the side opposite 30, you're going to multiply by the square root of 3. So I get 11 square root of 3 times the square root of 3, which is 11 times the square root of 9, which is 11 times 3, which is 33. So x is 33 for the side that's opposite 60. Number 22. When we look at acute, obtuse, and right triangles, we are doing a squared, b squared, c squared, and then we're comparing the length of the hypotenuse and so on. So we're going to go 4 squared plus 6 squared and compare it to 9 squared. So these two together are 52. 9 squared is 81. And when the hypotenuse squared is bigger, that is an obtuse triangle. Then we'll do the same thing for the next one. So I'm going to compare 5 squared plus 6 squared, and I'm comparing it to 7 squared. So I end up getting 61 on this side when I add, and 7 squared is 49. So when the legs are smaller, that ends up being an acute triangle. And then one more, 12 squared plus 16 squared, and I'm comparing it to 20 squared. And we get that 400 is equal to 400. And when they're equal, that ends up being a right triangle. Number 23. So the geometric mean, the math itself is not too bad, but you do have to memorize the equation. And it's the square root of a times b. And so we're going to go ahead and do the square root of 10 times 18, which is the square root of 180. And then we have to break this apart, right? And if this is a multiple choice question, you could compare the decimals, even if the answers are in radicals. But let's practice breaking it apart. So I can obviously split this into 18 and 10, 9 times 2, 3 times 3, and then 5 times 2. And I take out all groups of 2. So when I come in here and look, I'm going to take out this group of 3 and this group of 2. Those come out of the radical, so 3 times 2. And there's a single 5 left over that goes inside the radical, so this becomes 6 square root of 5. Number 24 asks us to find the missing length of the side, and we notice that we have a right triangle, and we know all of the sides except one. So I'm just going to call it x for the sake of solving. And when we have two of the sides, we're going to do a squared plus b squared is equal to c squared. And remember, c has to be the hypotenuse, which is the side opposite 90 right here. So 7 squared plus x squared is equal to 11 squared. 49 plus x squared is equal to 121. Subtract 49 from both sides, and I get x squared is equal to 72. And when I square root 72, we can round to the nearest tenth. That's what it's asking. And I get that x is equal to 8.5. Number 25. So these are the ones that I prefer drawing our triangles out because to memorize the equations can be difficult and it's easy to make mistakes. So I'm just going to go ahead and draw my smaller triangle and my larger triangle, and I'm going to label what I know. So on my smaller triangle right here, the short side is 6, and the hypotenuse is x. And then I have my big triangle, so I'm actually going to use this bigger triangle. And I know the short side is x, and this hypotenuse is 6 plus x, so that's 20. And now I have enough information, I could set up a proportion. So I'm going to go ahead and go x over 6 is equal to 20 over x, and we cross multiply. So x squared is equal to 120. We square root. X is equal to, you could get a decimal, but let's practice breaking it apart too, because I feel like that's a skill that we should be practicing. So I'm going to go 4 times 30, and 2 times 2, and 2 times 15, and 3 times 5. So again, I can only take out groups of 2, which is one single 2, and then square root. All of these single numbers go back inside. So 2 times 3 times 5 all has to go back inside, which ends up being 30. So same thing with number 25. I'm going to go ahead and draw my triangles. So my smallest triangle, the short side is 4, long side is y. And then I'm going to go ahead and draw this medium triangle right here. Short side is y, long side is 12, and the hypotenuse is x. So right now I'm going to go ahead and solve for y. And I'm going to use a proportion. So y and 4 and 12 and y, I'm going to set up a proportion. So y over 4 is equal to 12 over y. Y squared is equal to 48 when we cross multiply. And we square root, and you can break apart 48. 16 and 3. And 4 and 4. So that is 4 square root of 3. And then when we look at this, if you read the question, you could do Pythagorean theorem to find x, but the question really only wants you to find y. So you can just ignore x for this question. All right, our last couple. So find the value of x to the nearest tenth. So we're rounding. And when we have 90 degrees with certain angles, we're going to use SOHCAHTOA. So I'm just going to go ahead and write that across the top for our reference. And then when I look at this first one, I have 20 degrees. This is side opposite and adjacent, so I'm going to use cosine. So cosine of 20 is equal to x over 6. And when there's a number in the denominator, we just multiply by that. So 6 times cosine of 20 is equal to x. And x is equal to... Nope, that's not right. Hopefully you guys caught it. But we can't use cosine because we have opposite and adjacent, and that's tangent. So we're going to start this problem over. So let's go ahead. Opposite and adjacent is TOA, that's tangent. So we're going to go tangent of 20, not cosine, is x over 6. And then we're going to multiply both sides by 6. So same setup. I obviously just chose the wrong function. So 6 times tangent of 20 is equal to x. And when I plug that in, I get 2.2. All right, moving on to this next one. Again, from x degrees, when we're solving for an angle, we use the inverse, but we're going to still set up the same. So this is adjacent and hypotenuse. Now we're going to use cosine. So cosine of x is equal to 14 over 24. And then we do the inverse of that fraction to find x. And when I plug that in, I get that x is equal to 54.3 degrees. This next one, from 23 degrees, 17 is opposite, x is the hypotenuse, so we're going to use sine. So sine of 23 is 17 over x. Now, some of us have learned by this point that if x is in the denominator, we can just switch the x and the sine function. But if you're still doing the algebra, that's great too. So we're going to multiply both sides by x. And we get x times sine of 23 is equal to 17. And then we divide by the sine of 23. And so when I plug that into my calculator, right, 17 divided by sine of 23, I get 43.5. All right, our last one for chapter 9, number 28. So an escalator from the ground to the second floor of a department store is 110 feet. So I'm just going to draw an escalator. Those are like what you take at the mall to go to the second floor, things like that. Okay, so the escalator to the second story. So this escalator distance right here, right, they look like those little step things, is 110 feet. It says it rises 32 feet vertically. So up and down is 32 feet. And then it asks, what is the angle of elevation? So remember, the angle of elevation is always at the bottom. And when we're solving for an angle, we're going to use the inverse. So this is like the middle example up above. So we have opposite and hypotenuse. So I'm going to go ahead and use a sine function. So sine of x is equal to 32 over 110. And I want to do the inverse of that ratio of 32 over 110 to get how many degrees is our angle of elevation. And we get that the angle of elevation, when I plug this into my calculator, is 16.9 degrees is the angle this escalator is going up at.